Hello everyone, welcome to the Gate Wallah. Today we are going to start the NIC PYQ series for Theory of Computation and Compiler Design. Very good evening to all. Let's start with the subject, and this is the lecture number. Of course, only we have one lecture for this, and I hope you are enjoying this series. And let's continue with the TOC and compiler. Okay, the first question, of course, every question will give 1 minute time. Just think about it, read the data and then try to answer each question. If possible, choose the right option here, which you have, and let me know. Yes, good evening. Yeah, Durga Prasad, yeah, Prashant, Jashwal. Okay, before starting these questions, let me help you the pattern which I have observed from the NIC. Yeah, Vaibhav, good evening. Most of the questions which are coming from the PYQ from the gate. So if you are having gate questions with you, so please practice it, and it will definitely help you for I can guarantee that the subjects which are there in the gate definitely will help you 90% of the questions which are similar or exactly as it is like a gate. Yeah, Sriya, good evening. Okay, so that's the one advantage for you who are preparing for NIC. So you have a lot of questions to practice. Anyhow, we had done PYQ series for the gate in the last year, so that you can watch for all the PYQ questions, but these are actually happened in NIC, so you can also look into them. Yes, sure. Okay, this is the first question. You will be having 1 minute time, so every question will just spend some time if needed. I don't know where to put, but yeah, time starts. You can just look and read the question and try to answer it. We'll find out what is the right answer. It doesn't matter 1 or 2 mark. Mostly 1 mark questions are there, but sometimes they can also copy 2 marks questions. Don't know, right? Some questions are related to the compiler, so better to if not there, not required to practice. But if they give any question from TOC, then you should be worried later. Okay, so if not there, doesn't mean that they may not ask, but 99% they don't ask. But they already have in the pattern, old pattern. Just prepare what happens, right? It's just one subject, and practicing the PYQs, it's fine. Okay, it's done, right? Okay, what's the answer? Yeah, B. Let's look into it. You have the regular, context-free, recursive, and 4 languages are given. Just you need to do which of the following are true. L3 complement, that is a recursive complement, is recursive. So anybody is asking L3 complement is definitely again recursive. And union with L4. What is L4? REL. So recursive union REL. So definitely REL. This is a true statement. And L2 union L3, that is a context-free union recursive. It's definitely recursive, not an issue. But you cannot say CFL. And L1 star, that is L1 is regular. L1 star is also regular, because it's closed under Clinic star or Clinic closure. So it is also regular. So L1 star is again regular. Regular union context-free is a context-free, because context-free languages are closed under regular operations. So it is also true. It is also true. And the fourth one, L1 is a regular, and L2 complement. Context-free complement need not be context-free, right? So this is context-sensitive language. If anybody says L2 complement, you can say context-sensitive language, but no guarantee of context-free. So it may context-free, may not be. So you are trying to do regular union context-sensitive language, you cannot guarantee context-free. So accept this statement. There's a 1, 2, 3. Do you have that option? Yes. So the last option is the correct, D. 1, 2, 3. You can see that 3 statements are correct here. 3 statements are correct here. Is it fine? Okay, let's go for the next question. As you know, TOC is not much important this time, so just you can look into them overview. Yeah. Some problem is there, X. Okay, just take 1 minute time, then we will discuss whether it is okay. If you know, just practice it. Otherwise, we'll just discuss quickly. You have a Turing machine over the input alphabet, any state q of m, and they have given everything. State q and w belongs to sigma star. The computation of m on w visits the state q without any limitation. Without any limitation. That's only the line you need to worry about. Whether m computes w while computing the w, or while running on w, will it visit the state q? Decidable? That's a very difficult question. How do you know it? It might go to never halt. It's about the Turing machine, right? It may not reach state q before deciding it. It might go to never halt case. If it is going to never halt case, the q may not come ever, and you cannot understand the answer. Okay, this is undecidable, no doubt about it, because you are not asking within 100 moves, within 1000 moves. If anybody asks within 1000 moves, yes, that you can verify. You can just take 1000 steps, but this might go to, there are two cases. Yes, you may get it, no doubt. Yes, we will have a logic, but if it is not able to visit, then it might have two cases, may halt or never halt. Two cases may come. If this machine never halts, then you don't get the answer at all. This is the reason this problem is undecidable but partially decidable. The reason is partially. If really reaches the state q, it will definitely say yes. If it is not able to reach, it may say no, or it may not say at all, because it may go to never halt. Okay, that's the problem. Undecidable but partially decidable. Okay, let's move on to the next question. Okay, this is another interesting question, which are all gate questions. That's why you can practice more from the gate, especially not TOC, but compiler at least practice all the questions from gate. Okay. Yeah, options, you can just take the option B is S1 is true and S2 is not necessarily true. Okay. S1 is true, S2 is not necessarily true. Yeah, we'll do that at the end. Gupta. Not required, just we'll complete the TOC as quickly as possible, then we'll go to compiler. Yes, Ria. Because any question comes from this TOC, you know, you should aware a little bit, right? This might help for even other exams if you are practicing. That's why we need to take care of this PYQs. Okay. So what is the meaning of this one? You have an algorithm that can effectively enumerate the words W1, W2, W3. That means that set of strings will be a recursive language. So there is an algorithm A to generate the language which has the strings W1, W2, W3 and so on. There is another language L2 which is going to depend on L1. You can see the strings which I have taken from L1, but L1 already has an algorithm because L1 is recursive language. Now what is the question is L2, you are going to form something like this: W1 hash W2 and W1 hash W3, and similarly W2 hash W3 and so on. And this L2 is given to you. Now there are implications. If L1 is recursive, L2 is recursive. See, L1 is definitely already given, L1 is recursive, but anyhow, if L1 is recursive, that means you have an algorithm to generate L1, then definitely L2 will be recursive, because this can be generated in effective order, means in lexicographical order, with the help of L1. How? You can see the L1 is having, like, let me show here, W1, W2, this can be generated in order, right? Already you have an algorithm for this. Now L2 we have to generate with the help of these strings. First you can ask the algorithm the first two strings W1, W2, and then you can generate W3, then W1, W3. Up to here you can also put W2, W3. You see that first I tried this, then I tried this, then we'll try this, then keep on generating, including all the strings, right, in a particular order. See, with this 4 strings we can take care of that. What is that? W1, W3 is covered, now W4, and W2, W4 is not covered, we can do it, and W3, W4, I can do it. So we can generate in a particular order by covering all of them. We are not leaving anybody. So this will be also recursive. We can enumerate in a particular order. That's called as recursive. And when L2 is recursive, you know already this is a particular order. You can pull W1, you can pull W2, you can pull W3. You can also get L1 back as a recursive. So both the statements are true here. Both the statements are true. A is the correct. Yes, Prashant. So in GATE exam, they have asked some questions like, L1 is recursive if and only if L2 is recursive. Even that statement is also correct because both directions this holds. Both directions it holds. Okay, let's move on. No timer is required for TOC. As you know, it's not there in the syllabus. So let's complete it as soon as possible. So you have the set of strings in which every substring of 3 symbols has at most 2 zeros. So you cannot have the 3 zeros because you should have at most 2 zeros. If you get a 3 zeros, you should go to dead state. So the dead state is also given here Q, correct? And then, so there is an example 0 0 1 1 0 and 0 1 1 0 1 are in the language because you don't have a 0 0 here. You have maximum 0 in a sequence. But if you look at here, if you take the 3 symbols consecutively, 0 is there. That's why this is invalid and these two are valid strings. Now you just need to complete this diagram. That's it. Options are there. Options we can look into them later. Okay, not required right now. You can just fill up easily. See, after 0 here 0 is missing, right? Yeah, we can take this. After 0 one more 0 comes, you should go to dead state. Why? Because 0 is not valid at any point of time, because you can see that the whole motion meaning is given here. And after 0 1 comes, suppose. So where it should go? The last 2 symbols is 0 1. So you can go here. Because you can see after 0 if 1 comes, last 2 symbols are 0 1. Because after that anybody comes, you need to remember them. So this motion is trying to remember last 2 symbols, but the third symbol will decide based on the transition. Okay. Now 0 1 0 is covered. From 0 1 if 1 comes, then last 2 symbols are 1 1. It's going to be here. Okay. And then similarly, you just look into 1 0. 1 0 on 0 is missing, but 1 is there. So 1 0, 1 comes, then 0 1 is the last 2 symbols. So it's going to 0 1. It's already there. But after 1 0 0 comes. After 1 0 0 comes. The last 2 symbols are 0 0. So you can go there. From here on 0, you can go there. Okay. From double 1, if 1 is there, self loop, because last 2 symbols again 1. From 1, if 0 comes, 1 0, that's here, the transition is missing. So you're able to cover everything, right? So they asked for some only, so that you can easily identify from the table. But here this table is magic. See, it's not like a general table. They have asked something differently. Like you need to observe at least one transition, what is the exact answer. So what they have mentioned here, this is the present state and this is the next state and this is the input they have given. Normally the input on the column heading and next state will be entry of the table. So they slightly modified it. Now you just look at it, 0 0 0 0 on 1, is it going to 0 0? No, it cannot. 0 0 on 1, it should go to 0 1. You can easily understand. So this table definitely not correct. Now look at this one, 0 0 on 0, it should go to 0 0. So this is also wrong. Now you look into it, 0 0 on 1, so last 2 symbols are 0 1. This is absolutely correct. And now look at 0 1 on 1, how it can go to 0 1? Because 0 1 on 1, it should go to 1 1. So this is the wrong table. And look at it, it's last one which is left, 0 0 on 1 0 1, that's right. 1 0 on 0, last 2 symbols are 0 0, it's going to 0 0. And 0 1 on 1, it's going to 1 1 because last 2 symbols will become 1 1, right? So this is also correct. And 0 0 on 0, so 3 zeros happening, and that's why it's going to dead state. It's a very important, it's going to dead state. This is also right. And 1 1 0, last 2 symbols are 1 0, it's going same. So option D is the correct. It's a very simple motion, but looks very big. The problem looks like very big, but answer is so easy here. Okay, and let's find out the next question quickly. Okay, language L for which there exists a TMT that accepts every word in L. Oh, I think there's a mistake here. Let me do that. that accepts every word in L and either rejects or loops for every word in L. So this is wrong. It's not, should be. Okay. There exists a TMT that accepts every word in L. That's one. And either rejects or loops for every word which is not in L. So this is very important. Accepting means it will halt at final. Rejecting or loops means never halt. Loops means never halt. Rejecting means it will halt at non-final. So there are two meanings here. Reject means it will halt at non-final. Loop means never halt. So which language will have that criteria? When you design a TM, this criteria will be applicable. When you design a TM, every word which is there in the language you will accept. Every word which is not there in the language, either you will reject or it will go to never halt. So this definition goes to recursively enumerable. So recursively enumerable languages, when you build a Turing machine, this property is applicable, right? So it's a very important. Okay, look at this two words. That accepts means it will halt at final. If it is not in the language, then either it can reject or it can go to infinite loop. That is the definition of TM. And when you have a TM and what language it accepts, it's simply what is the language accepted by TM. That's the meaning. That's it. What is it? It's REL. Instead of saying simply language accepted by TM, he has given old definition of the TM. That's it. Okay, let's move on to next one. The logic of pumping lemma is a good example of which one you can see here. It's a pigeonhole principle as it applies the pumping concept here. So this is the pigeonhole principle. Option A, it's a straightforward and that will not take much time. And this question is also easy, which was also gate question. X power n, y power n, which is given already, such that n greater than or equal to 1. So which of the following definition generates the same language as this one? You can see here which one will be equal to among these three. So this is the grammar, right? Is it generating the same? Look at that option. 1 definitely generates the same because this X, this E production, the recursive production will generate equal X and equal Y, and minimum is XY, and the next string is double X double Y and so on. But this one cannot guarantee equal. It's a regular expression obviously. The minimum string is XY, but next you can generate, you can see double X double Y. Up to here is fine. But the third string you will see even triple X double Y also possible. But this string is actually should not generate because it is not there here. So this one is wrong. And X plus Y plus minimum is XY. But next to minimum is double XY possible because X plus means I can generate double X also. So this one is also not equivalent. So only one, that is option A. Yeah, option A is correct. Yeah, can you do it? Next one. Any issue with the voice? No, right? Choose the correct statement. The correct statement is there is a relation between partial and total, right? The total function, every total function is definitely, and most of the books also believes this statement, but some will contradict with this statement. That's fine. But every total function is a partial function. So that is the option B. The relation between is that total functions which will help us to do the recursive language concept and partial functions which will help us to compute the recursively enumerable languages. So here this kind of concept can also be help us to relate with the recursive languages and RE languages. REs, okay, not one, all of them we are talking about here. So every recursive is recursively enumerable, same way that every total function is a partial function. That makes the option B is the right. Okay, and this is already covered, so no need to worry about this question. Okay, this is also one of the easy question. Some machine is given and you need to do the complement of the language. Be careful, it's not the complement of a machine, right? There is no such word complement of a machine, it's the complement of a language. So what is the language? First understand, minimum 1A, then epsilon A. So you can get 1A, 2A, 3A and so on. It's just A plus, right? If you do the complement of this L, then A star minus A plus, which will be, there's a sigma star, right? Sigma star minus L. So sigma star is A star, L is A plus, and this will be just epsilon. except epsilon, everything will be accepted. When you do the complement, you will get only epsilon. So only 2 is the right here. Yeah, only epsilon that should be. Okay, but don't interchange the states, final and non-final. That's only for DFA, but this is not the DFA. Remember, it's given here NFA with epsilon moves. So don't do interchanging final, non-final, will not work. Okay, L be a language and L complement be its complement, that's fine. Which one of the following is not a viable possibility? Not possible, that means. So now find out which is not possible at all. L and L complement both are not RE. Is it possible or not? L and L complement both are not RE. So this is one of the question, people confuses because they may have the less knowledge in framing the questions. See, L and L complement both are not RE is the possible, right? This is possible. That means L is not RE and L complement is also not RE. Both are possible. Okay. Next one. One of L is RE but not recursive, other is not RE. So even if L is RE but not recursive, its complement is not RE only. So this is also possible. When L is RE but not recursive and do its complement, then definitely L complement will be not RE. This is also possible. This is also possible. So it is possible. Now we have to choose it, another one. L and L complement RE but not recursive. It's impossible because one is RE but not recursive, other definitely complement, definitely not RE. This is impossible. Okay, here both are recursive, so this is also not, it's no need to say possible, it's a true statement basically. It's a possible, it's actually true statement. Okay, anyhow, so answer is C, which is not possible. If they ask which is possible, then you have to choose A, B, D. Which is not possible, you should choose the C. Yeah, C is the right. Okay. My focus is completing TOC as quick as possible so that we can begin with that compiler, as you said. Let L1 be a recursive language, L2 be REL. So L1 is a recursive and L2 is REL. Oh, recursively enumerable but not recursive. So complete that sentence. It's a very important. So L1 is recursive and L2 is REL but not recursive. Then which one of the following is true? So let's begin. Choose it. First one, complement of L1 is recursive. That's true. Complement of L2. Can you say RE? If you do L1 complement, it will be recursive. But if you do L2 complement, you will get a not RE. As you know, RE but not recursive complement is not RE. So now choose it accordingly. So option A is wrong. As you see here, L2 complement should be not RE. So L1 complement is recursive, L2 complement is not recursively enumerable. So this is the true statement. And let's go for the option C. L1 complement, you can say recursively enumerable because it's already recursive, but L2 complement you can't say. That's why we are not able to choose it. And D, L1 complement you can say recursively enumerable because already recursive, and L2 complement you can't choose the recursive. That's why you can delete it. So only the second option is correct. Okay, palindrome cannot be recognized by any finite data. What would be the reason? Just find out. FSA cannot remember arbitrary large amount of information. That's true statement, because if it can remember, then it can check its reverse possibly. And FSA cannot deterministically fix the midpoint. When you have a W, any palindrome, right? Suppose you have W power, even length palindrome I'm talking about. So do you know where exactly the reverse will begin? That also not possible to understand by the finite automata because there's no marker at least. And even if the midpoint is known, finite automata cannot find whether the second half will be the match with this first half. Like if you know the ash is here and the first W, its reverse is here, still you cannot find. So all will be the proper reasons why finite automata cannot do the palindrome concept in, correct? Palindrome concept in the regular languages. Every regular language you take, you will never see this palindrome concept. But if you want to accept the palindrome strings, then the language should be finite. But infinite language you have, then this palindrome concept cannot be recognized by the finite automata. Reason is everybody will look like proper reason. Okay. If L1 is the CFL, L2 is the regular, which of the following is false? Okay, you know that if you do regular operations with the CFL, then the first one, CFL minus regular, this is fine because CFL minus regular will be CFL intersection regular complement, which will be same as CFL intersection regular. So this is the CFL, no doubt, because CFLs are closed under the union and intersection with regular languages. The next one, L1 intersection L2 is a context free. That is CFL, this is the same thing, right? CFL intersection regular is definitely context free. So second is also true, but we need to find the false. And complement of L1, is it context free? That complement of L1 means CFL complement need not be CFL, right? The actual statement should be need not be CFL. So this statement is a false statement. So we can choose this option C. And as you need to choose a false, so you will go for the option C only. Option C. So don't choose A and C. That's A, L1 minus, oh, sorry. It's a not, oh, I'm very sorry. L1 minus L2 is a not context free. I was reading like context free. Okay, it was my mistake. So A and C is actually correct statements. So this L1 minus L2 is a not context free, but actually we got it is a context free. So that's why option A is also false. Option C is also false. Yes, true. So that's why D is a correct statement. Okay, I hope you got it right. Okay, which of the following is wrong? Just read. Turing machine is simple mathematical model of general purpose computer. You need to choose the wrong statement. Turing machine is a simple mathematical model of a general purpose computer. Is it true or false? And second one, Turing machine is more powerful than finite beta. Is it true or false? And the last one, Turing machine can be simulated by a general purpose computer. So if in simply you can see computer is equivalent to Turing machine. This is a very well known Church Turing thesis. The reason is if you give enough memory to the computer, then computer will work like a Turing machine. So Turing machine can be simulated by general purpose computer. See, this is somewhat restricted. The reason is what? General purpose computer has a limitation, but can be simulated if you give enough memory, infinite memory to this, it can be simulated. So Turing machine has no limitation at all, but it can be simulated by adding some memory to it. So see, except C, Turing machine is a simple mathematical model of general. Mathematical model is right because you can change the configuration. A is a true, B is a true. In the C, there is somewhat simulated. It's not possible directly by general purpose computer, just you need to add. So here, none of this is there. You can go for none of this, but you need to choose one statement. That's we can choose. We cannot simulate directly by general purpose computer, but by adding the infinite memory to the general purpose computer, you can do that. So it's possible to simulate, but not directly. Okay, this statement is absolutely valid when you add the infinite time and infinite memory to the general purpose computer, that it will work like a Turing machine. Okay, so don't worry much about it. Given two DFS M1 and M2, they are equivalent if when we say two machines are equivalent, if they represent same language. Where is that statement? M1 and M2 access the same language. That's the definition of the equivalent word. Two machines are equivalent, it means two languages, the representation L of M1 is same as L of M2. So if you want to say two machines are equivalent, you should say that their representation should be same, their languages should be same. Okay, so this was, it's not exactly what they are talking about. This language, when you look at it, right, either it should start with 00 or 01 or 10, right? But it's not what they are actually expecting here. Strings not starting with 11, only the matching here, but that's fine. Strings of odd length you cannot guarantee because you can also have even length. Strings starting with 00, that's fine, but it's not only starting with 00 but or 01 or 10, and strings of even length no guarantee, odd length also there. So appropriately matching with strings not starting with 11 is fine, but it's not exactly the same language. Remember that strings not starting with 11, you can say it, but it is not going to generate all the strings which are not starting with 11. Example, epsilon is not starting with 11, 0 it's not starting with 11, single one not starting with 11, but these strings are not generated here, right? minimum length is here 2, but this 3 strings should be there in this if you are saying, okay, appropriately, as they are not asking you in all exactly the language represents what, okay. But actually this is also wrong option. As per the gate, if they give this, you can challenge and you can get the full marks, but it is a job, so you cannot challenge anyhow. So anyhow, which of the following machine model can be used in necessary and sufficient sense of for lexical analysis in modern computer language? Anything, C, Java, whatever you say, the which is necessary and sufficient. Finite automata would be sufficient to represent the lexical analysis, to design the lexical analysis. So you can do it, but if they don't give necessary and sufficient word, you can choose all the options here are correct. Even non-deterministic finite automata, when that is also correct. What is it? Non-deterministic, I think there's a typing mistake here. They could have given something non-deterministic PDA. So this B and C are correct here. Finite automata, that's absolutely correct. And this I think option C is different. It's exactly a non-deterministic push down automata, maybe. I feel that, okay. So just look at non-deterministic finite automata is there, that's why we are choosing to, but actually option B was the correct and C is something else, okay. But if they have given BC something like this, then you should choose both of them. But anyhow, MSQs are not there, then don't do that. Which of the following problem is not NP complete? Not NP complete, but it is undecidable. So if you look at this, right, partition problem and Hamiltonian circuit and bin packing all are NPC problems, NP complete problems. Even click, there are so many similar problems are there which are NP complete, but halting problem, you already know it is undecidable problem. If you have studied undecidability, is a very well-known problem, halting problem, membership problem. These problems are undecidable in general, okay. Okay, I think that's about TOC. Now we'll go into more detail. So what's more important for compiler? So first we'll complete the questions, then based on the observation we can look into it, the very basic questions that you can observe from the compiler. So let's look into it. So all gate syllabus is there for NIC again. Now you can start practicing for the compiler. In compiler, see that the relations between the different parsers like SR, SLR, LR, LELR and LL parsers. So this is the first kind of question. Okay, you can practice now. I'll give you time, a minute. 1 minute. Very easy question. Which of the following statements about the parser are correct? CLR is more powerful than SLR. Is it true? Obviously. SLR is more powerful than LLR. No. SLR is more powerful than CLR. No. How many are correct statements? That's easy, right? You just know the relation, that would be sufficient. Nobody is asked you to construct, just knowing the relation, right? What's the relation you have? SLR is less powerful than LALR and less powerful than CLR in general. Using this you can answer it. CLR is more powerful than SLR because CLR can understand more languages, more grammars than SLR. Correct. So most of you have done correctly. Yeah. That's option A. Correct. So just use this relation. SLR is less powerful than CLR. SLR less powerful than LLR. And when you look at from this side, LLR is more powerful than SLR. CLR more powerful than both of them. Okay. Yeah. This is another kind of question, but no, you may take time if you don't know SDTs. So learn SDTs, at least the LR evaluation. What we say that the L attributed evaluation. Don't go for the LR evaluation, which may take time. Okay, just design, simple parser. That's why they didn't ask a very big question here. It's a very simple question, and only your focus is on the string AAB. It's a very simple one. AAB. You can make a very small machine and do it very quickly. Just it takes 1 minute hardly. If they really give very big question in this kind of exams, especially like NIC, you don't say very lengthy questions. Okay, many questions that you can learn in gate or somewhere, you can copy paste them directly. When we say syntax error, if this AAB is not possible to generate, then we say directly click syntax error. Okay, which one? You're getting C? Okay, let's see that. So everybody is getting C. In covered, yeah. In course, it's definitely there, but it was a gate question also. That's a one more lucky. Okay, what do you do? Simply you do generate that string as quickly as possible, AA, and A has to do remaining AB. Is it possible? Just try it. Yes, and B. And S has to generate A. You got the string, right? AAB. Now what you do is just take all the what? Just give me color. Okay. So now we have, there are so many translations, right? There is a one translation here, there is a one translation here, there is three translations totally. So now first you will print this, then this one, then this one. Just look at S to A. What is the print? 2. So it will print 2. Then A to SB, that is a print 3. Then finally S to AA, that's a 1. So 2, 3, 1 is the output. That is the option C. Very easy if you know the evaluation. How do you do for the L attributed grammars, right? Anyhow, there are no attributes, so you're lucky. So we have only actions to print. Yeah, this is another definition. This is epsilon free context free grammar. If for every pair of productions A derives U and A derives V, so what is here? Just find out. It may not take even 1 minute if you can understand the options. Yeah, exactly, Sudeep. So that's a one more lucky. You can just remember, sometimes if you are not able to understand because of less time, you can also pick the same answer that you choose in the gate. Did not change even, right? But this was not gate question, I believe. Okay, some questions they have new. Epsilon free, it was, you know, interesting question too. Even for gate people, this question could be very important. It was not there even in gate, but it's very important concept. What is LL1 grammar? For the epsilon free context free grammar, if you don't have null productions, then if for every pair of productions A derives U and A derives V, so what is the meaning of this one? Anybody got the answer? Anybody got the answer? If you don't have null productions, you can simply choose, if you have anything like A derives alpha 1, alpha 2, you simply do intersection of this two is enough. First off, even this was a shortcut for checking LL1. First of alpha 1 intersection, first of alpha 2 should be empty. If it is not empty, right, then there is a problem with the grammar, it is not LL1. So is empty, then the CFG has to be LL1. Yes, if it is equal to pi, then we can say these two productions have no issue, but you need to check every such. That's why they have given every pair, not one pair. Every pair they are talking about this. Every pair you have is empty, then you can say LL1. And if the CFG is LL1, this CFG only we are talking about. Remember, if this CFG is LL1, then first of U intersection first of V has to be empty. These two statements are true for the epsilon free context free grammar. Remember that. If the grammar is not epsilon free, then this statement is invalid. So anyhow, the C is correct, epsilon free context free grammar. Why there is one more point is missing? If you have the null production, then you will have another rule, like first of alpha intersection follow of A you have to do. This has to be empty, then we say LL1. So when you have a null rule, then follow of the LHS of that production is going to come here. So there is another rule if you have epsilon in the grammar. So this is only for epsilon free context free grammar. Two statements are correct. Either way it is true. Okay. Yeah, next question. Synthesized attribute can easily be simulated. Synthesized, you know, S attributes, right? What is it? Which grammar? So you remember the grammar, there are so many types of grammar, LL grammars, LR grammars. So in which kind of grammar this can be easily simulated? Synthesized. Synthesized means you need to do something different. Synthesized means only you should go from bottom to up, not, okay. That's a very important to understand. Synthesized, yeah. Top down is a kind of inherited concept. You can, coming from parent to child is a different relation you get. Okay, synthesized means you need to evaluate first bottom, then you should go up. That happens in which kind of grammar? Okay, you mostly go for in LL grammar. The mostly they are top down parsers we use, right? In top down parsers we use this grammar. In top down parsers we do not understand how the child is computing. We always go from parent to child. But if you want synthesis attribute, then synthesis attributes depend on the parent. So if you want to know the child, right, so if, sorry, parent depend on the child, so child will be computed first, then parent. So you'll go from bottom to up in the synthesis attribute. So in ambiguous grammar we don't understand anything here, but LR grammars we have that relation, bottom up parser concept. LR parser or LR grammar, even SR parsers. There are many names to understand LR grammars, right? LR parsers, SR parsers, shift reduce parsers. Okay, you should use LR grammars to understand synthesized attributes, because you can evaluate from bottom to up. You know synthesized attribute definition, right? At any node the values will be computed based on the child. So if you want to compute here, you should use the child value here. Let's say S, A, B, and if you want to compute S value here, then it depends on A and let's say B. Something like this. If you know the values here, then you can compute at S. Otherwise, you know, synthesized attributes cannot be evaluated. Okay, what is the maximum number of reduced moves? Means simply the number of steps in the reverse of RMD, or you can say RMD also, because the number of moves will not change. Okay, that can be taken by a bottom up parser for a grammar with no epsilon, and the unit production they mention clearly. Not only this A derives A, see unit means symbol to symbol. Here one symbol, here one symbol. A derives A, and already you know unit production something like this comes. So these two kinds of production should not be there. Okay, to parse a string with n token, n with n, okay, n taken, okay, n symbol, I think n, the n is a string length. If you take n length string, then how many number of reduced moves? Okay, the hint is something like this. I want to produce, let's say, of course 0 length impossible, 1 length impossible. You should start from 2 length. If you want 2 length, you can take, you know, you can derive AB. Of course in reverse what will happen? The same, one reduced move. In RMD it's a one substitution, that's it. So in reverse, or you know, normal RMD, it will take just one move only. So just in reverse you should write AB reduced to S. Okay, another one possibly, if you want 3 length, let's say ABC, how is that possible? I know you may go substitution for, let's say, 2 length. You can take something like this. How? Small a and capital A, and capital A can substitute with a BC. Total how many steps it will take? 2 steps. In reverse also it will take 2 reduced moves. So you can use RMD, reverse of RMD. So here you takes 2 moves, 2 reduced moves. Here 1 move. So what is the relation between the length and the number of moves? Anybody got that answer? It just simply B is the right answer, correct. N minus 1. When you take 2 length, you got a 1 move. When you get 3 length, you got 2 moves. Either 2 substitutions or 2 reduced moves will be same. Just you need to understand reduced moves means in reverse order. So 1 reduced move, second reduced move here. So 2 reduced moves here, here 1 move. And similarly you go for 4 length, you will get a 3 moves. So what is the relation between length and number of moves? N minus 1. If you take n length, you just get n minus 1 moves. It was a gate question, right? If you could have practiced there, you just copy paste. In a compiler, keywords of a languages are recognized during. It was so easy question here. Not only keywords, identifiers. In the exam, they may ask anything. Keywords, identifiers. What else they may ask? Operators. So many, right? recognize during. I think you don't need a timer for this. Okay, just you can answer it where it is. Anybody still thinking? Just take the timer then. In which phase this kind of strings you will recognize? The first phase of the compiler, the starting, you will group the characters and you will make, right, you will identify them. Exactly, the C is the right answer, right? Lexical analysis of the program. It takes not much time. In the parsing of the, during parsing, what do you do? Syntax. During the code generation, what do you do? The assembly code. Basically you generate assembly code. Not recognizing, I'm talking about what you will generate. It generates assembly code. Okay, it will take the 3 address code and it will generate assembly code. And during the parsing of the program, it will verify the syntax. And during data flow analysis, it will identify some kind of optimizations. Okay, a system program is a system program that combines the separately compiled modules of a program, like different modules of a program, into a form suitable executable, or it makes one program. It looks like it makes one program, even though you have a lot of modules and they compile separately and makes a single execution. What is that option? The famous definition, actually it's a linker, but you don't have a linker here. They have given, instead of linker, they have given linking loader. Okay, because you need to load them, anyhow they want to use the loader as a terminology, but linker is actual terminology. But here linker, only one place is there, it's option B. Yeah, the identification. Okay, you take the time because many people might analyze a different way this question. I can put 3 star for this question because it was not asked, I think, in the gate so far, but it is there in NIC exam. Identification of common sub-expression, read completely because you may misunderstand if you read off. And replacement of runtime computations by the compile time computations. So that instead of doing runtime, you can also do compile time. What kind of the optimization that is? Okay, everything you do, it's just looks like common sub-expression, but what should be that common sub-expression in this optimization techniques? That can you do before the runtime. During compile time only you can do that kind of replacement. This is another word that is very important. What happened? No answer it. It's a theoretical question, right? There was no answer it. Local optimizations, we don't replace the runtime computation with the local, not all of them. Some of them you may do it, like especially constant folding. The constants, instead of doing at runtime, that you can do, because anything which you write, even 2, this is expression only, right? 2 plus 3, even this is expression only. If 2 plus 3 is appeared many times, that you can fold to 5 and don't compute at runtime. You do it compile time and replace 5 wherever you see 2 plus 3, right? So 2 plus 3 is the expression which is a common sub expression that you can replace before runtime only. So it's a constant folding. Okay, loop optimization, it's a code motion. There are many things. You can't replace the runtime computation with the compile time. That's not possible. Data flow analysis, data is important but not the constant there. Okay, like live variables, these things are they are not the constants. Okay, the graph that shows basic blocks and their successor relationship is called as basic blocks. When you get the terminology and you have a name, but just find out which is. Yeah, the actual, say this is a confusion, right? The name is actually, what is it? Control flow graph. Control flow graph. We also say it is CFG. What do we say? CFG. We don't say context free grammar, that's a different, okay? This control flow graph, normally when you say flow graph, it can be, anything, but it's mainly the control flow graph. You can also call control graph. Yeah, because you have the successor relationship, you can say that is edges. That edges we call controls, correct? Because you have always jumps there. So unconditional or conditional doesn't matter here. So we have the controls to relate with the basic blocks one with other. So we call the control graph. So actual name is control flow graph. It's simply flow graph is not enough. Flow graph can be, flow chart or something like that. Okay. So be careful that flow graph, don't choose it. Just flow graph is not enough. But control flow graph is the actual sentence. And maybe they have used control graph, but there are many types of graphs, data flow graphs, control flow graphs, but it's about control. Okay. Yeah. So you may argue that why not flow graph? Yes. Why not? That's a very important, because we are talking about here mainly controls. That's why we say control graph or control flow graph. A top-down parser generates. I don't think you need, its top-down parser uses to generate the string what kind of derivation. Okay. They should frame properly, but it's fine. Top-down parser uses which of the following derivation to generate a string. Okay, that's straightforward, leftmost derivation. And if they say rightmost derivation in reverse, this is for the bottom-up parser. Okay, this is also possible in the gate question, in the NIC question directly. So such questions are, copied from the gate, and even gate also these questions were there already. Very easy. Okay. SDT, syntax directed translation scheme, is desirable because is it based on the syntax? Is it easy to modify? A description is intendant of any implementation. Let's see who will answer it. And most of the time you be careful when you see none of this, all of this, and carefully observe it. There is a possibility of that. Okay, there's a possibility of going for none of this, all of this, or both A and B. When such special options are there, and mostly the answer could be there because they don't frame in general in that way in anywhere. Intendant. Description is intendant of any implementation. Is it independent? I think looks like its description is independent of any implementation. Yeah, option C. Correct. Okay, let's look into the, because it's based on the syntax, because the name itself says SDT. SDT follows the syntax, because after syntax only semantic comes, right? If you are really using the SDT, you will follow the syntax to get a meaning. So if you don't have the syntax, definitely you should not, right? First is true, no doubt. It is easy to modify, like if you want to change the semantic, right? It's easy because you only need to change the translation. You will not change the syntax. Syntax are already fixed. Like if you have x is equal, let's say y plus z. Is it concatenation or is it, what? Is it addition? It's a very easy to, add the translation meaning. Easy to modify and easy to append whatever you wanted. So the translations are easy to do that. So it's easy to modify because of the SDTs will allow, rather than changing the syntax, you can change the translation, that's enough. So based on that, that will work. And the description, no need to depend on any kind of implementation in the world, because you can make your own unique implementation with the help of SDTs. So no need to work on other implementations, like C may have a different implementation, C++ could have different, and Java could have a different implementation. So no need to depend on other languages or other, SDTs to depend. So this kind of implementations are unique to them, and they can have their own translations or rules. We call them translations or rules. And based on this syntax, you decide what kind of translation is required. So blindly you can choose for the D, right? This 3 could be obviously right. The reason is you have all the advantage with the help of SDTs, because it's based on the syntax, it's easy to change the translations, and no need to depend on any kind of implementation specific to what you want into that programming language. Okay. Yeah. The output of the lexical analyzer, yeah, input, output, what is it? It's very easy, right? Already we had completed one. The input and output. What is the input and what is the output of the lexical analyzer? Both you are aware. The input is just a sequence of characters. That is your program basically. It just looks like sequence of characters. The output is the sequence of tokens. That sequence of tokens, you may call it as the here set of tokens. Yeah, actually a sequence of tokens. That sequence they have called as set, but actually the sequence of tokens. Okay. Set of regular expressions. Oh, that's a different. Strings of character. I don't know. It's a string. You can't. Syntax tree. There's output of what? A parse tree. Sorry. Output of the parsing phase. Syntax analysis. Okay. The another one. The number of tokens in the following system. This is a two types. Two times this question came. So you may careful about this kind of finding the number of tokens could be a challenging for you. So this time if TOC is not there, there is a high probability to ask the questions from compiler. Okay, just look at how many different types of tokens are there. Total number of tokens, not only different types, it's total number of tokens. Printf and open parenthesis and double quote, comma, I, even comma twice came, but you have to count total. Both of them you have to count. And ampersand, I, closed and semicolon. Okay, do not count ampersand pi as a single token. Why? Because ampersand is the operator, I is the identifier. So both should be two different tokens. So 1, 2, 3, and this whole thing comes as a string constant. So you should count as a one token only. 4, 5, 6, 7, 8, 9, 10. So total 10. Yeah, most of you have answered D. That's an easy question, I guess. Yeah, peephole optimization is a dash. Okay. Maybe code optimization was not there in GATE so many years, so we'll see less questions in code optimization. So you can read from other exams if you know, like ISRO, TF, or any other. If you find any optimization questions, you read from there. Okay. Peephole optimization basically very few set of instructions where you cannot take a lot of instructions there, so which will be applied to very few set of instructions. So where could be that possible? Constant folding is it's a part of the instruction, right? You cannot choose the constant folding. Constant folding comes under peephole optimization, but peephole optimization need not be constant folding. Remember that way. And constant folding may not be possible in assembly code especially, but peephole optimization will be used for low level optimization. If you carefully observe, loop optimization requires a lot of instruction support, and even they are very far, you may require them in the loop optimization. And in the data flow analysis could be whole function, you might be doing data flow analysis, or it might be whole program. So data flow analysis and loop optimization requires a lot of instruction support, but the local optimization is the best example for a peephole optimization, where you take very few instructions, and if you want to do local optimization, then choose the peephole optimization, and there you can choose a very simple instructions like you want to do apply like copy propagation, or copy propagation also applicable for data flow analysis. You can do for far away, but you can also do for very few instructions also. Okay. Like constant folding if you are doing at intermediate level, but that's peephole for low level code optimization. Which one of the following statements is false? Okay, there you need to take time to read, but could be easy. And it was GATE question too. Context-free grammar can be used to specify both lexical syntax rules. Is it true or false? You need to choose the false. Remember, don't choose a true statement. type checking is done. Is it before passing or after passing? Look at that. High level language programs can be translated to different intermediate representations. Yes, like C, C++, Java. Do they require to represent same intermediate code? Not required. Arguments to a function can be passed using the program stack. Yeah. Which is a false statement among all of them? False statement, just false statement we require, not true. Remember, don't find the true statement here. True statement you just ignore, and false statement you identify. That's also very easy. Even you don't understand many statements here, there is a statement which you already have an answer. Oh, don't do that mistakes. And even you don't understand option A, C, D, the type checking is done after passing. Here before is given, but you know type checking will be done in semantic analysis, and this is a false statement, right? It's clearly you can understand, and others you may or may not aware, because context free actually we use for the syntax, but you can also use for the lexical. Why? Because context free grammar is more powerful than regular grammar. Regular grammar can do lexical analysis, right? Regular grammar can be used for the lexical phase, but now context free grammar you can use for both lexical and syntax, right? Because context free grammar can even you can write a grammars for those which looks like regular languages. So this lexical analysis rules, they depend on regular languages concept. That can be done with the context free grammar also. This is a true statement obviously. And high level language programs, no need to be translated to the same intermediate code. Different is fine. You can use different, it's fine. Can be is there, right? They're not restricting. Arguments to a function, like you have the function arguments, you want to pass to function, then you use the program stack, right? That's a very important in programming languages. This is also true. And only the statement which is very easy, type checking is actually done during the semantic analysis. The semantic analysis will happen after the parsing, but they have given before. So you choose B. Okay. Some code optimizations are carried out on the intermediate code because it was a gate question. So I feel that you can choose if you know the point. Okay. This was a gate question too. Okay. Some code optimizations are carried out on the intermediate code. Why do we perform intermediate code? What is the reason? Okay. They enhance the portability of the compiler to other target processors. Okay. You need to understand the meaning of this line. Okay. If you not, then you may go with that, whatever. Program analysis is more accurate on intermediate code than on machine code. Accurate? Accurate, what do you mean by that? Accurate, is it? Okay, the information from data flow analysis cannot otherwise be used for optimization. Why cannot? The information from the front end cannot otherwise be used for optimization. Okay, no one, right? Some code optimizations, why we do on intermediate code? Do you know what is the advantage of intermediate code? If you have the intermediate code, you can do the portability of the compiler, because you no need to implement the whole compiler, right? All the 7 phases you no need to implement together. You can make 2 pass compiler. You can make 2 pass compiler, 1 pass. It's independent. It's dependent on the programming language. Other depends on the machine. Other depends on the machine. So there are, you know of one thing like lexical analysis, syntax analysis, and semantic analysis, and what else? ICG. This whole thing you can implement separately, and code generation you can implement separately. So that code optimization, why we do here, the reason is if you have the better code, you can enhance the portability of the compiler, because this compiler you are trying to port on other machines. See, now this is whatever the output you get, right? If there are different machines, this is a machine 1, machine 2, machine 3. The same code you may apply everywhere. But if you don't have the better code here, then what happens? This may take much time, right? So that's why you do the code optimization on intermediate code. The output, the same output you can apply on different machines. Even though the C is depends, of course you know that the compilers are depends on the machine. So the whole compiler no need to build together. So this compiler you can make two passes, and after getting the one pass output, the output you can same output you can apply on all the machines, even though compiler is the machine dependent. So what you do is enhance the portability of the compiler, because in that compiler the one pass you are trying to do the optimizing. So that is the target processor means target machines basically. So it can enhance better way. It can reduce or it can optimize the code. That's the right answer. Okay. So A is the actual suitable answer, because that's why we do intermediate code generation, and you may require the intermediate code output. And if you learn C, C++, Java, if you really want to implement the compiler, like after C, if you want to invent another compiler for C++, no need to build whole compiler. Only you just change lexical, syntax, semantic, ICG, and this part you can keep the same for all the kinds of compilers. The advantage is for them, the code generation is the same. Only the first few phases are different from one programming language to other programming language. So you can choose that the option A. Okay. Program analysis is analysis of the program is, if you want to analyze the program, you don't need intermediate code, right? You can do it at high level also, right? The more accurate in high level rather than even intermediate code, that you cannot say that. The information from data flow analysis is not otherwise be used for optimization. Who said that the data flow analysis can give you even more, information to analyze the live variables and so many things. Okay. From the front end, the information, you can't understand the statement at all. Everything has the information, right? Front end, data flow analysis, everybody has the information to optimize. Okay. Assume that the SLR parser for a grammar G has N1 states, and the LALR1 parser for G has N2 states. The relation between N1 and N2. Oh, just you need to understand. I'll give a relation. So if you know, just answer it quickly. And it was a kind of gate question which was there already. What is the answer? Not enough this. It's just mentioned N1 is the number of states of SLR1 and N2 is the number of states of LALR1. Even they ask the exam number of states in CLR. Then you can make a relation. You know this point already. These two are always equal, and the number of states for the same grammar, it might be equal or less than the CLR. So if you say this is N1, N2, N3, so keep N3, N1 should be equal to N2, but this two either less than or equal to N3. So the answer will be both should be equal. N1 is necessarily equal to N2. It's a straightforward question in compiler, and for that you may require a lot of examples to understand why always you have equal number of states in SLR1, LALR1, because here if you have two states are having same productions or same items, but they may have a different lookets, you will combine into the single state. So that makes the same number of states like LR0 or SLR1. Even there is one more, LR0. If you really know that number of states in LR0, that is will also same as number of states in SLR1. Okay. Yeah, this was a previous question, right? Okay, slightly, I think they have done any mistake here doing copy paste. Okay, looks like some things are printed double. Okay, if this is the question, we'll answer it. Okay. Yeah, question is changed, the options are also changed, so we can believe these options also. 1, 2, 3, 4, 5, 6, 7, 8, 9. You have answer, right? Okay. We already did this, I guess. What is the right answer? Printf. It's an identifier, and parenthesis, then string constant up to here, and then comma. Here I ampersand I, which is like an expression, right? Even though it has syntax errors, but you don't need to worry about syntax errors. I ampersand I. So there are 3 tokens in that, and close parenthesis and semicolon. You have total 1, 2, 3, 4, 5, 6, 7, 8, 9. So option A is the correct one. So there is a difference between the previous question and this question. Here I ampersand I is there. So here these 3 are different tokens. Remember, you cannot assume here single token. So A is the right answer, correct. Easy one. Yeah. LL1 and LR0 techniques are, this is just power, right? So you know the relation between the power, you can easily answer it. Just take time to answer it quickly. What is the relationship between the power? When you're talking about power, is it both are having same power? Do you have any relation between them? Just find out. If you wanted to know the power, that you can say, LL1 is having less powerful than LR1, that you can say, but it's about LR0, so be careful. And if you want to compare the power between different LR parsers, SLR is less powerful than LALR, less powerful than CLR. That CLR only you call it as LR1 basically, or LR2. Many names are there. Both same in power is a wrong statement, no doubt. Both simulate reverse of rightmost derivation. Is it true? The LL is a top-down parser and LR is the bottom-up. Do they really follow the rightmost derivation, reverse of rightmost? No. So both simulate a reverse of the leftmost derivation? No. So they are actually incomparable. So that's a true statement. Why? Because LL1 will follow leftmost derivation, LR0 will follow a reverse in RMD or of RMD or RMD in reverse. So you cannot choose any of this ABC. You should go for the last option. Again, I am saying both are not having same power, and they don't come. We can't compare basically, because some grammars which are LR0 which cannot be LL1, some grammars which are LL1 which may not be LR0. So you cannot compare them with who is having more power, who is having less power. So that's option A. It's a false statement. Both simulate, both are having different ways to derive. So you can't choose option B and C. So D is the right answer. So SR parsing can also be called as, or just could be very easy. I think no need timer for this. SR also called as what? The LR. You can use the LR parsing concept because these two are belongs to the same category, right? Now they follow which derivation? Reverse of the rightmost derivation. So we simply choose A. But if they really ask top-down parsing or LL parser, then you go for leftmost derivation. Okay. Yeah, I think these are the easy PYQs. So you see that so many questions we did in very less time. The reason is they ask very straightforward questions. We did not have much calculations. So the intention of this job oriented questions, especially they expect to do a lot of questions in less time. So in that duration you may require, yes, that's what happened, right? You see, you have the questions on maximum it may take 1 minute time every question. If you can do, even they can take in seconds if you could understand all the patterns and you remembered the questions from the gate. Okay, so if you observe the questions where you see the relationship between the different LR parsers, one kind of question you see, and you see a lot of questions on LL parser, like finding whether the definition of what the LL1 grammar when the context free grammar has no epsilons, right? And relationship between LL and LR. These questions you have seen a lot, and some questions related to the code optimization. Yeah, so you lexical syntax semantic errors, if you see, yeah, I don't know exactly where do they focus, but if you look at here, there were no questions related to the errors category. But in case if they ask, go for the gate questions, lexical errors, you focus on grouping the characters. If you're not able to group the characters, then definitely lexical error comes. The syntax error, which will focus on structure, that if you miss any parenthesis in balanced way, or you miss any semicolon, or you know the syntax, right? If you have the for statement, if you miss some semicolon to while mentioning 3 statements, such things can be focused very easily. All right. Now, when you have the both lexical and semantic errors, you will always focus on first lexical. When there is no lexical error, then only you will go for syntax. When there is no syntax error, then you will go for semantic. No, you cannot say, Gupta, that way. If both lexical and semantic errors are there, you will focus on lexical only. It could be possible there might be typing mistake, but actual question, you look into the gate, and if there answers semantic error, then there was no lexical and syntax. See, when there is lexical error, how cannot be it is syntax error? You tell me. If you are saying lexical error, definitely it could happen somewhere syntax error, right? Gupta, how can be you saying only semantic and lexical? Maybe misprint, that you can say, right? If there is a lexical error, there will be chance of syntax and then semantic. Okay, so don't worry about it. There might be printing mistake. Fine. All right. I hope your preparation is going well, and we're always we are always there to support you in any kind of exams which is after BTech or during BTech that you are facing, right? Prerequisite. See, when you are going for NIC job, you don't need any prerequisite. Remember that, because here the questions are straightforward, and you just need to know the concepts, and very simple concepts. No need to spend much on construction of different parsers and tables. You don't require a lot. Just go with the theoretical concepts lot. I said, right, they look at how many questions you can answer in less time. If you want to do that kind of strategy, then you need to learn a lot of concepts, a lot of definitions, and a lot of relations. These are more important than solving many individual questions. So they did not ask any time find the grammar is ambiguous or not, because that may take time. Instead of that, they frame a lot of theoretical statements, and that's what happened. One SDT question we have seen so far, that's also, you don't need pen and paper for that. So you want for NIC or you want for what? The gate. If you are looking for the important questions for compiler, the focus on a lexical analysis, lot of theoretical questions you have, finding the tokens, and which machine is used for designing lexical analysis. You have direct state questions there, like for types of tokens, identifier, keyword, or operators. So any important theoretical points you can focus on. In the parser, don't focus on constructing state diagrams, all these things, but in the parser you focus on relations between parsers. Any two parsers, you have relations, you find out them, and relations between different grammars like LR and LL grammars. And we have seen a lot of questions in finding the number of states for SLR and LLR. What is the relation? Okay, such all relations you focus on it. And apart from that, you just know basic definitions, definitions for what? The LMD, RMD, reverse of RMD. They did not ask even definitions. They may ask in future, but know about the definitions, and they may just give what is LMD, what is reverse of RMD, just put into the picture. Okay, in the parser, and there was no question related to operator precedence parser, so we may not predict it. And there was no question related to especially they did not give any grammar so far, looks like. So theoretical statements, you focus on it, and you may focus on definitions for ambiguous, unambiguous, CFG, and what is the relationship between ambiguous and ambiguous with LR, LL. So any relation that you have, just focus on it. And when it goes to SDT, no need to focus much. Focus on attributes like what is inherited and what is synthesized, and focus on evaluation of SDT. That's it. How to evaluate SDT? Use only one technique. Which technique? The L attributed evaluation. So only one technique you follow always. Put all the transitions down and evaluate from left to right. So that would be sufficient for this exam, I guess. Okay, and then intermediate code, there was no question. If any question comes from the intermediate code, and that is mostly like, you know, syntax tree, or you can focus on syntax tree and 3 address code. They may not ask more about SSA code and other like DAG and many things. But in code optimization, I think this, you have seen a lot of questions. So code optimization, a lot of theoretical points, not the practical points. Remember, in code optimization, focus on a lot of definitions and relations, and why we use the what constant folding, why we use local optimization, why we use data flow analysis, or any kind of automation that you study, and a lot of focus on theoretical points. So I hope this whole compiler can be prepared even within 10 hours, I guess, and it may not take even more than 5 hours if you have the right data with you. And just focus on these things, and mainly you see that code optimization, lot of questions and lot of relations here, and these 3 topics you can focus a lot. Okay, lexical analysis and the parsing, a lot of theoretical points between the parsers and grammars, and then in the code optimization, know about a lot of techniques, and then know about the definition. At least they will give, you know, this optimization cannot be applied or applied, so you can easily identify them. So this is about a compiler, and I guess you no need TOC at this time, but if you really want to focus on TOC and what questions you focus, did you see any question related to the regular expressions or not? No, right? So this regular expression, easy questions only, go for it. And here you may see the grammars. So CFG, context free grammars, you can focus on it. And then there was no push down automata question, there was no but much questions are there on decidability, undecidability. And these 3 topics looks very important for the TOC, but you asked only important, right? These 3 topics you focused a lot, and other topics you may go with basic questions and basic concepts, which will work for the NIC exam. But in compiler, as you know, compiler you have in the syllabus, so better to focus on a very few things in each topic. In lexical analysis, look at how to find the tokens, and what kind of rules we use in lexical analysis, like maximal munch rule we use. Some theoretical points they may ask from here. Okay, so no need to go for an entire compiler, everything in detail, like computing first set, follow set. They may not ask you, but have a few basics how to compute at least, because they may ask which of the following is the first set computation definition. Okay, yeah, I hope I covered what you need. Thank you so much for joining today's session, and see you in upcoming sessions. Bye bye, take care. All the best to everyone who are preparing for the NIC exam. Yeah, see you. Bye bye, take care.